Let me just share my screen. You can stop sharing as you wait for the anaconda to download.
Download.
Yes, after it is done, you will just install it. I think it's just a simple task to install anaconda. So I want us to continue from where we left yesterday. And if you have a question about yesterday's lesson, you can just raise up your hand and ask. I'm hoping that you guys are able to see my screen. So someone can just confirm that. Are you guys able to see my screen? My screen, I mean. Someone,
Yes, I can.
okay, okay. Yes, you can open your Colab for those of you who are using Colab. The ones that you are using VS Code, you can open. And let me just open yesterday's file. So yesterday we just introduced to ourselves what is variables, and even we studied variable rules. You also able to see the operations that you can do on strings. You were able to see how to get the length of a string. You're able to see how to slice a string, looping through a string. You were also able to check how we do negative indexing. I think you also did string concatenation, and I think today we are to continue from string count. I think we also checked about how we do capitalize the first letter in a string. So any question from yesterday's lecture before we move to string count? Again, this one is a string operation, uh, and I've used an inbuilt function that is count. This is the string method. The method that you use to to do what, to count the number of words, or the number of times a certain word appears in a string. So like in this one, someone to tell me what is this. Let me just call it text. Is a text. I can just change it to text. So in this case, text is the variable name, and the value that it holds is I love apples, comma, apples are my favorite fruits. It should be I love apple. It should be apple. Then we can just say that apple is my favorite fruit. I think that makes sense. So if we want to know the number of times, like let's say, just for example, the number of times that word apple appears in this string, you can use this count function. It is an inbuilt function. So you just have to use the text variable dot count, and then inside now these parentheses, you should now add the word that you want maybe to check the number of times it appears in your string. So in this case, we are checking for apple. I think we can just run these. So initially we have it like that, but we can assign, because this text dot count and then apple, it will return a value, because we are just trying to check the number of times this apple word appears in this text. So that value we can install, or we can store that in a variable again. So we can call this variable result. So result is equals to text dot count and then this apple, and then we are going to print now the results. These results a variable here, but in this case it's holding some value, the one that is going to come from this text dot count apple. So let us just run this and see. So I think it's running, and we are getting the output is 2. I think I can just modify this a little bit. Let me just call it output, and then I can just use a comma to separate that. So our output is 2, and this is showing that the number of times this apple word appears in this string of ours is 2. Um, we can put a comma and say maybe apple. We say an apple a day keeps keeps doctor away, just to check if you are going to get 3. Yes, and our output is 3, simply because we have added another instance of apple in our string. So that is how this count function operates. Yeah, that one is another operation for strings. So any question, or any person who is not understanding what we are doing. So any question? Any question? Eric, are we together? Peter?
Yes.
Yes, are we good?
Yeah, we're good.
Okay. Okay, I think we can just continue. That was all about string operations. So we had count, we had how to slice, we had how to look through a string. We did concatenation, capitalize. So those are just but a number of operations you can do on strings. So I think we are just going to move forward to something else. Um, Let me just check something here. So I think you can just move to, is it int? That was, you can move to int. So these are just notes on how we are talking of definition and usage. We are saying that count method returns the number of times a specified value appears in a string, and we have its syntax, and the syntax is string.count, and then value start end, um, and then we have a parameters description where we have value is a string, and the string to 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 value to like the value to search we are searching for uh, in that string. The other one is and start and end are optional, and that's why that is why we just inserted echo. So, but it isn't mandatory to use start and end. These are just index, but in this case we don't want to we don't want to use these indexes. That is the start and end, and you can see clearly from these notes that those are just optional parameters. Um, so we are saying that in programming, you often need to know if an expression is true or false. So I think this is why we were having Boolean, and I think you can just you how we check Boolean values is very simple because we use these uh, like these expressions to just check if a statement is true or false. So we can check if maybe 10 is greater than 10, and definitely that is true. And if we run this, we are going to get a true. A print again, we can have 10 is equals to, and most of you now are beginning to wonder why I'm using double equals. You will get to know that soon. But for this case, we are just trying to compare two values, and that is why we're using these two equals means this one is a comparison. We are just is it a comparison operator? This one we just like comparing the two values. But if we used one is equals, that one is also called an assignment operator. But we are going to get to know more about these operators. So again, you can check if 10 is less than 10, 10 is less than 9. Of course, you should get a false. If you run this, you're just going to get the output was here initially, this one. Um, so we are saying that most values are true, uh, and almost any value is evaluated to be true if it has maybe sort of a content. Uh, I think we can check that using the bool. This is the bool function. Is a shorthand of boolean. So you can check bool, and then maybe we just give it a string, or maybe you can give it even a number or even a list. But you will get most of these, as we are seeing here, that most values are evaluated to be true. A boolean, that is bool ABC, bool 1, 2, 3, bool this list of values, that is apple, cherry, and banana. So if we try to execute this, we are just getting they are just true. So and that is why we are saying that most values are evaluated to be true, and these are just examples. So we are just saying that any string is true except empty string. If we had an empty string here, this one will evaluate false. I think you can just try that. These are just simple cases of learning boolean types. Let me just run that, and now you can get that simply because this one is an empty string, we are getting a false. The other thing is any number is true except a 0. So I think you can just try that by running this. Um, Let me just run that. Let me just comment on this. And we are getting true because this one is not a 0. But if we, in case we put a 0 here, you're supposed to get a false. And that is what we're getting. Uh, also, we are talking about any list, tuple, set, dictionary are true, except that the ones that are empty. So in our case here, this is a list, and a list is defined by having two angled brackets. These are how do we call these brackets? I think the are good ones are these. These are square brackets, and we define a list by square brackets. This list is not empty. It has three elements, and if you are to execute this, you are going to get a true. But if you happen to delete the content of this list, again we are going to get a false. Let me just try to run that. Yes, false. I think that is all about Boolean values, and I don't think we have like to go through all of them because this is a repetition of what I have just said. Because you get a boolean 0 is false, a boolean empty string is 0, a boolean what? A boolean empty string and a tuple. Again, they will give an output of false. So that was just checking of you were just checking the boolean stuff. They are just that simple. Um, so let me just get into yesterday's stuff. Yeah, let me just open this. I should open a file not let me just open this file. Yeah. I think we are supposed to be here. I think it's opening uh, something that you guys won't be able to understand. Let me just I think you can just use this file. Let me just try something out here. Okay,
James,
I'm
yeah,
receiving sharing. I
we
think
lost your screen.
yes,
Okay.
I'm receiving sharing. I think I've clicked stop sharing. But I'm hoping now you are able to see my screen, right?
Yes, yes, yes.
Just a minute. Good. I think we can continue. I think just to continue with yesterday's work, we can move forward to learn what are comments in Python. And comments, I think while I'm writing codes, I think you have seen instances where I'm using hash. So comments, they will help us to not execute some lines of codes. So like in this case, let me just have this hello world program. So if you notice, several lines here are commented out. So and if I happen like to run these, you're just going to get hello world simply because I've commented all the other content. So this means that in this cell, the, the, the only line that will execute is just this one. So by having this hash hash in front of any line of code, is it's like this one is now a comment. So we have several types of comments, and we can just begin by learning why do we use comments in Python. So the first thing that uh, or the first reason that we use comments in Python is, the first one is to, you can use comments to explain Python code. Let's say maybe you are writing a code, a Python code that is maybe more than 100 maybe lines. Uh, you will need to explain what you are doing, or in some instances even you forget what you are writing. And comments are the comments will help you to explain what you are trying to do. Like this one, if I'm trying, let's say, to write a hello world program, I can explain what I'm doing here by having these. Maybe this is a hello world program. I think this is better compared to just having a print hello world to any, let's say, even to any person. Maybe uh, it was your first instance to come across maybe a line of code. You just get a print, and then you get some parentheses and some speech openings and closing speech marks, and inside it you have hello world. I think you are just going to get started. What the heck is this? But if you have a comment that is maybe trying to explain what you are doing, I think that is better. So this is a hello world program. Uh, yeah, so the first thing is to explain the Python code. The other one is to make code more readable. The other one is used to prevent execution while maybe testing codes. I think that is too advanced. But again, it will prevent execution while testing codes. So now, how do we create a comment? I think I've already explained that. And these are just example of code. These are just example of what comments. We have a comment does not have to be text that explains the code. It can also be used to prevent from executing the code. Like this one. If at all I have to these lines of codes, and I can just comment out this. Let me run this. So you get I have now 3 lines of codes executed. The first one is hello world. The second one is hello world, and the third one is cheers mate. So you notice that in a way I'm repeating myself here. So I can just comment out these to prevent prevent running of this line. When now I execute this, I'm going just to get two outputs. So that explains why we use comments to prevent executing of codes. Um, we can have a multi-line string in case now you have maybe a paragraph to explain your code. How do we get a multi-line comment? Um, a multi-line comment, you can I think you can still use the hash stuff, or you can use the three opening speech marks, the ones that you are using to again define a variable that has more than one line of string. So again, this one, if I execute this, I'll still get a hello world here. But now this one is in this instance, this one is a comment, whereby I'm using three. You can just delete this, and so you have to make sure that you open this comment with three opening speech marks, and also closing it with three speech marks. So in here you can write any comment, like this is a what? This is a multi-line what comment. I think that is enough. So if I execute this, I'll just get the print hello world. Yeah, I think that is what we were supposed to cover yesterday. I don't know if there is a person with a question regarding strings, regarding comments. Yeah, I think that is it. That is what we were to cover yesterday. So, any question before we get to lecture 2? Any question? Any question?
James,
Yes.
let me ask something.
Yeah.
So, how will we be applying this one? What is the application part of this string thing?
Okay. Uh, I, I think yesterday I started by saying that these are just building blocks for writing code.
Okay.
So whatever I'm just doing now is I'm trying to give you what an overview of what will be you will be doing when maybe writing some code.
Mm,
So like you have to learn how do we comment, how do we how do we how do we initiate a variable, how do we assign a value to a variable. Those are the kind of they're just building blocks,
mm.
and then we'll get to the real stuff. Uh, I think that is answered. Or do you have any other question? Let me just open the lecture too. If there is no other question, we can have this. And let me share the second stuff that you're going to learn here. Good, let me share my screen. Let me share this. So I think today we will be checking what are Python operators. And Python operators are used to perform some operation on variables and values. Uh, so we have operators divided into several groups, and the first group is arithmetic operators. The second group is assignment operator, and that is comparison. We have logical operators, identity, membership operator, and bitwise operators. So we are going to check one by one, and we are going to start with Python arithmetic operators. So arithmetic operators, these are just common operations that you use to do in your basic maths. That is addition, subtraction. We have multiplication, division. Uh, I'm assuming that most of you have come across modulus and exponential. We have also the floor division. So these are kind of uh, operations and arithmetic operators. So I think we can try to implement these, starting with addition. Let me just add a cell here, code cell. Let me just add something here. So let's say I want to, let me just try to add that cell somewhere here. You can just operate from here, here up. So I'll start by what? By initializing these variables. So I have, let me just use first number. I think that will make more sense. First, nope. And I have second nope. Just to break I think most of you are used to X and Y. By this time, I think we are just going to use the first nope and the second nope. So this one is a variable name, and I'm assigning this variable name to a value of 2. And the second variable, I'm assigning it to a value of 5. So I want to do some operations on these numbers. That is the first nope and the second nope. So, and I'll start with an operation that is addition. How do we do addition in programming? So it's quite simple. Of course, I'll just have let me just delete this. We're just going to have, let's say we can call it addition. We can assign, how we do that is the first nope plus should be first nope plus second nope underscore nope. So basically that is how we do operation, but instead of printing this one directly, we can again assign this value to another variable. We can call that variable addition. Addition is equals to that. Um, so this is the what? Um, this is this is how we do addition in Python. So to see the output, we can now print. To get the output, we must print, and now we are going to print addition. Are we together up to that point? So this is how we print the results. We do the addition, and then I think we are good. So and then now we print the what? We print the output or the results. I think we can even call this one results. Results, and then I want to see the results in the console. The results here. So when I run now these, if I were to run these, I should get, what is 2 plus 5? I think most of us know is 7. I think I can, let me just add another cell here up so that we can be able to do these operations. Let me just copy. In fact, I can copy this content here. I want to paste it somewhere here. Let me just delete that. And just cut that on to, you can just have operations. Then we can start with the first one, what? Addition. I think you can start with that. So when I run these, I should get 7. I don't know if you guys are able to see the power of having variables. So if now I want to change the value of first knob, I can just put maybe 12 here. And now if I run this, I'll get now 17. So I can just manipulate these numbers, these values as I want. I can even add 58. I can add maybe just even a bigger number. It will just give me the output. So someone can use maybe a calculator to check if this is right, but it should be the correct answer. So simply, this is how we do addition operation on variables. It's just that simple. Any question up to that point? Okay, thumbs up if you can understand that. Ladies, okay, yeah, I think most of us can understand that. So
James, can you kindly repeat again, please?
okay, so I'm saying yesterday I started by explaining what is a variable. So and this is my first variable, that is the first number. Let me just use the number, first number, Yes, I think that makes sense. So the first number, I'm assigning this. I'm assigning it a value of this number here. It's a big number. Even I don't think I can edit this. Let me just reduce it to 1200. I can also reduce this one to maybe 500. 500. So we said that a variable will hold it's like a it's a memory what it's a store. It's going to store some values based on based on based on what you want it like to store. In this case, I want this first number to be I want it to store 1200. That is 1200. That is value of type. This one is of type integer, and I want also the second number to be the second variable to store 500. Again, it is of type integer. So if I want to add these numbers, normally how do we do, like, okay, what is the procedure of adding two numbers even without using a program? You'll just have to write that is the result that you want to get, that is first underscore number plus the second underscore number. So if now in the normal case, you are just going to write that your result is, I think this is how you are doing some mathematics. You're going to give your answer as 1700, right? And yeah, so what I'm trying to do now with the computer is just writing a program that can add two numbers. That is the first number and the second number. And I want to give the result of this addition to another variable here that is called results, just as you do normally when you're doing some arithmetics. But I can just comment that. So I'm assigning this result to the value here. So now, so that I can see instead of writing the result, by writing results here is 1700, that means that I have done that using my head or maybe a calculator. But I want now the computer to do this addition for me, and I want to see the answer. So here it will do the operations, and by using print, now I want to get the results. So when now I run this program here, I'm going to get 1700. But this one is so obvious. What about of a big number, like uh, just any number like this one? And even maybe I can have another number here. If I tell you to add this number for me, it might be tedious, especially if you don't have a calculator. And even typing these numbers in the calculator again, it will be tiresome. So I can just get the answer out of this by just clicking this button here. And this is the answer. You can see how our program has simplified that. So any question up to that point?
James,
Yes.
like it is in Excel, are you able to put the separators like commas so that we are able to read 1,000, a million, billion, like this and that?
Or using now the commas and the stuff. I think with programming you will just have to write you will just have to write them without even those commas. The computer will understand that language of the numbers that you have inserted here.
Okay, that means the numbers will never be human friendly. It will only be for computers.
In a normal case, I don't think you'll have to add these numbers. These are just for examples. Uh, yeah, I don't think you have to separate them using commas. You might get some errors because again now it will. I think I'll have now to tell the computer that this one is an integer. I don't have to. I don't want to explicitly do that using the int function. So, but For this case, we can just use them without commas. Yeah, are we good, James? So let us just move to the next operation now that I have explained that. And now the second operation will be what is it? You have it? Subtraction. Again, this one is similar to. You can just copy what? Let me just copy this. I think I can have another. Let me just have another cell here. And this cell, I want us to carry out subtraction. Subtraction. And I want to, let me just use the numbers that you can validate answers. That is 125 and maybe 5. Let me say, if at all now I want to get the difference between all the what the difference between the first number and the second number. I'll use a minus sign. So again, I'll just have to change this operator between the first number and the second number. In this case, the results we are supposed to get maybe 120. Let us just run this. Oops, it will change. I think we failed to do what to update this. Let's just try to update this. Yeah, I'm getting the results as 120. And again, the importance of now using these variables. You can see in the second cell, I didn't again like have to initialize this first number and the second number. I'll just use them throughout because I already have them here. And that's why if I was maybe, let's say, to add let me not complicate stuffs here. But if you have your variables here with your values, you don't have again to initialize them here when you come to subtraction operation. So I'll add another cell here to do the multiplication this time. You can just call it mult. You can just multiplication. I'll again just change this sign to the multiplication side, and the result here that will be 25. 125 times 5. I think I can just run this first and get the answer. And then I'll copy this here. Good. You will continue like that for the rest of the uh, arithmetic operators, that is division, modulus, exponential, and floor division. I think it's just that simple. I don't have to repeat that. So if you allow me, I'll just move to the Python assignment operators. I think you can practice the Python arithmetic operators with the division, modulus, and the exponential. We call it exponential, and then floor division. Uh, Let me just move forward to Python assignment operators. And I think I had mentioned it has something to do with assignment operator. I called equals an assignment operator. simply because we are just trying to we are like just assigning 5 is equals to this variable is equals to a certain number, in this case 5. We are just assigning x to 57. You are assigning again here x to plus what? Plus is equals 3. This one is same as this. X is equals to x plus 3. Let me just show you an interesting thing here. This must be interesting. Let me so let me say x is equals to 3, and let me just have x is equals to no plus 3 here. Let me just print something like x. So who can guess the output for this? Now that you have learned that x plus is equals 3 is same as x is equals x plus 3. This one is another, this one plus is equals is an assignment operator. So I'm just trying to ask you guys, what should be the output for this? Let me just call it output. So who will give us the result for this? I think we can start with ladies first. Someone, Peter Kanyo is saying that the output is 6.
I also think the output is 6.
Okay. I think we can just run this and see what the heck is happening here. Yeah, we're getting the output at 6. Simply because this one is same um, x plus 3, and this implies that 3 plus 3, which is equals to the 6. These are just simple. We are trying this. Who is having an issue with doing these operations? Any person with a question up to that point? I think someone is having an error here. Get output is comma separated. So someone was just Oscar was just giving you a format to get your answer as a comma separated value. But Oscar, at this point, I think you are just going to complicate stuff. But that is the right syntax. I just don't want to to complicate things at first. So I think that is exactly that. For that, the next assignment operator is a negative is equals. A negative is equals again is same as x minus 3. So if we were to change this sign here, and we change that one to a minus. This means is x minus, and you're supposed to get a 0, right? Yes, the output will be 0 simply because it's 3 minus 3. So anytime in programming that you see um, these normal signs, that is the plus, the minus, the multiplication, uh, they are just implying this. If it is a multiplication, that means that is x times what? Times the value of x. So again with modulus, again with floor division, again with or this also means that this double asterisk, it just means that you are trying to find the x power 3. Then you can just try that. If I was to have this, I think we should start with this. So again, what is that for this? This just means that it is x power what? X power 3. I think we should get something to do with, is it 27? Because it's 3 raised to power 3. I think that there is nothing difficult with these assignment operators. So in your free time, you can just try the rest. That is the add, the or. You can even just try this. Then yes, at your own free time. I think you can get into the third operator, and that is the comparison operator. And in the comparison operator, we have operator name and example. So again, this is where I was saying that double is equals is a comparison operator. So if I have x is equals y, it means that I want to get the Boolean output for this is x is equals to y. So I'm just trying to compare the two variables, that is x and y. This one is called not equal. Again, this one will give me let me, in case I have less 5 not equal 10, this one will give me a true. Just mean that. So you have, if I have 5 not equal 5, this one is definitely a false, simply because 5 is equals to 5. We have the greater than, we have the less than, we have greater than or equal to. You guys know this. Any question regarding the comparison operator? Or you can have, let us just have an example. Let us have an example here. You can have I think you can use these variables again. That that is the first number and the second number. What is this? It's here. So let's say I want to go to compare if the first number, first underscore number not equal to second underscore number. I think I'm getting an error because of indentation. So if I run this, what should be the output? I think it should be true because the first number and the second number, they are not equal. Right? But if I were to change the first number, let me just change this one to 125 again. Now you notice that the first number and the second number is equals to, they are equal. So if I try to run this, let me just try to rerun this, and you'll notice that this one will be a false. I don't know why it is not, why I think I haven't updated these values. Let me just run this again to update those values, and I rerun this. Yes, I should get a false because the first number and the second number, they are equal. So this one again is just a comparison operator. I think you can use the is it the greater than or equal to? Let me just try to use this. You see the output. This one is true simply because the first number is equal to the second number. Yeah, I think that is all about comparison operators. They are mostly used when also writing programs. So I think we can move forward to what Python logical operators we have, and, or, not. So this one will return a true if both statements are true. So for example, if x is less than 5 and x is less than 10, it may be the value of x here initially. You can let us just have x's. Our x to be what? To be 5, no 2 or 4. You can just use 4. So if my x is 4, 4 is less than 5, and 4 is less than 10. So meaning that the output for this expression will be true. But if this one was maybe, let's give it maybe what, 7, we are going to get a false simply because 7 is not less than 5. Although 7 is less than 10, but now we need for this one to execute true, both the expressions on the left and the right hand side, they should be true. I think the last time you had to create a truth table, but this time I'm hoping that you have understood that. Or should we create a truth table here? Did we get that? If this expression is true and this one is true, we are going to get a true output. But if either of this one is false, we are going to get a false, simply because we are using the add logical operator. But in case of or, uh, either of expression must be uh, is it true? I mean, either of the expression can be true. I think we should let us just have an example here, just to explain that. Let me just copy this. Let me just copy this. Um, let me just have this here. Let us just try to let me just try to illustrate this. Let me say that my x is equals to 5 and my y is equals to something like 7. So in Python, again, indentation matters. So if I try to indent this, you notice that I'm getting some errors here. So you should not have indentation in this Python unless you are trying to maybe indentation comes when you want to, let's say, maybe create to differentiate between where the maybe for loop or maybe any loop, for loop, that is where loop, maybe a function in a class where it starts. But when you have an indentation while initializing a variable, you will get an error. So you can simply see that if I put my cursor here, I'm getting an expected indentation. So you'll always get this error of unexpected indentation. That you should start uh, from this margin here. So I'm saying if I have these two, let me just copy this. Uh, in fact, I can just start with the first one here. Let me just copy this here. If I try to execute these, I'll get a false. Why? Because our x here is 5 and 5 is not less than 5. That is why I'm getting a false here. Uh, although now we have 5 being less than 10. So and that is why we are saying here that this one returns true if both statements are true. But in this case, your first statement is false. But if I had something like 4 here, this one will execute true simply because both statements are true. We can go to or. With or statements, we are saying that it returns true if one of the statement is true. We don't care how many statements we have, but if we have one statement that is true, it will execute. It will return a true stuff. You can check that with maybe, let's say, 4. This one will still execute true because one of the statement is true. Note will reverse the results. It returns false if the result is true. Let me have this. So if I execute this, I'm getting a true. If now I wrap this one in some parentheses here, and I start with a note, uh, you notice that I'll get a false simply because I've negated the initial results for this expression. Um, I think that is enough explanation of that. Any question? I think that is just enough explanation for that. So let me just move to identity operators. And identity operators are used to compare objects, and not if they are equal, but if they are actually the same object with the same memory location. Um, so we can have the operator here and the description. These are the operators that we have in the Python identity operators. That is, we have the operator is and is not. So starting with is, this one will return true if both the variables are the same objects. Um, so we can have an example of x is y and x is not y. So I think I've introduced again something new here, because I've introduced a concept of no memory location. I don't know how I'm going to explain that, but I don't know the tool I have here. I don't know which is the best tool to draw some. It's snippet sketch. Let me just use this. I don't want the one for sleeping. I just wanna, but I think what I'm trying to say is, let me just use the intro. I think I have the intro stuff here. Just to explain something here. Let it open. You can just give it a few minutes to open. Just a minute. If you can. Is it opening? Let me try and open it again. I think it should be opening. Intro. let us just give it a minute to open. I think I don't know why it is not opening, but I want. Oh, yeah, it has opened. I want to explain something here about memory location. I think I can just open as I don't know. I don't know why it is. It's not opening. But I think I'll just have to explain without a diagram. So what we have are these. Let me just have an x. X is equals to 34 and y is equals maybe to 45. So these values they are they are stored in a memory location. So at the time I'm just defining my variable name here, and just using the equal sign here. My computer will set a memory, uh, just a memory for the value that I'm going to put here. And that is why that is the reason we are told here. How is this? Like, is not. We are talking of not if they are equal, but if they are actually in the same, they are the same object.
Please, James, I don't hear anything.
Oh, I think I'm speaking on a muted mic. Yes, I'm on a muted mic. Sorry. For how long have I been in a muted mic? Okay, I'm sorry about that. I don't know how I I don't know how I muted that mic. But I was trying to explain that uh, here we have something these identity operators that these identity operators do. They just compare we are just like trying to compare if the object are in the same memory location. And that is why I was saying that if I define x is equals to 34, this 34 is stored in a certain memory location. So, and y again it will be stored in a different memory location. So, is or is not is these are operators that are used to check if both variables are are in the same memory location. So if they're in the same location, x is let's say y, it will return true. I think you can just check this with an example. Let me just have that example over here. These things, they're just easy. You just have to understand these concepts. I think you can have that here. X is equals to 34 and y is equals to something like 45. If we talk of x is y, and then you just happen to execute these, you are going to get false because x and y, they are not in the same memory location. But now if I have x is equals to 34, and then again I have my let's say what, if at all I can say x is x, I can just try and check this. Now I'm getting as x is equals to 34 and x is equals to 45. They are now in the same memory location, and that is why I'm getting a true here, simply because they are in the same memory location. But that one doesn't matter so much. You shouldn't grab that. Um, it's just for explanation. So the opposite of that uh, will be what? Will be true if use is not. So if you happen to have two variables here, that is x and y, we have y, and we happen to say that x is not y, this one will execute as true, simply because x and y, they are not in the same memory location, and they are not the same objects. So I think that one is simple to understand. So we can just move to Python membership operators. The membership operators are used to test if a sequence is presented in an object. We can have operator, description, and example. So we have in, returns true if the sequence with the specified value is present in the object x in y, and not in. So by object I mean either it can be a list, it can be a tuple. I think we'll introduce to ourselves that. I'll explain this while using a list. So yes, at a tuple, I think that one will give us a good explanation. So I think, having said that, we can move to the last operator, and that is Python bitwise operator, whereby I have add. This one is or, and add sets each bit to 1 if both bits are 1, and or this I think now you can have a truth table for that, for the Python bitwise operators, whereby you'll have x and y. By bitwise operators, you know I'm dealing with binary, and binaries is either 1 or 0. So now with 1 and 0 we have for combination. We can have 1 and 1, we can have 1 and 0, we can have 0 and 1, and we can have 0 and 0. So if now I'm using the AND, it means that it will sets each bit to 1 if both bits are 1. So if I have 1 and 1, the truth value of x and y will be 1, simply because we are saying that and we'll set each bit to 1 if both bits are 1. And that is, in my case, is x and y. We have 1 and 1. But now if we have 1 and 0, then I'll get a 0, and that will apply to the rest, because now I have 0 and 1 and have 0 and 0. So that is exactly that with operator AND. But when we come to OR, we have OR setting each bit to 1 if one of the two bits is 1. So if we have we talked of setting each bit to 1 if one of the two bits is 1. So again, we can move now to this one. I think we should this one should be a pipe, an OR. I think it should be like that. So we have 1, 1, 1. I think we have at least one bit is 1. So we are going to get a 1. We have 1 and 0. Again, you're getting 1. We have 0 and 1. You're getting 1. And 0 and 0, we are going to get 0 because we don't have at least one bit being a 1. We have both of them, both being zeros. So we can move to XOR, and we are told that XOR sets each bit to 1 if only one of the two bits is 1. It will set each bit to 1 if only one of the two bits is 1. So we are going to get a 0 here because both bits are 1. But for XOR but we are told that the XOR will only set each bit to 1 if only one of the two bits is 1. But in this case, we have both x and y being 1. So, and that is why I've assigned this one to 0. I think for the rest will remain 1 because sets each bit to 1 if only one of the two bits is 1. So in a case where we have two zeros again, it will still be 1, simply because we just need, we are told that it will set each bit to 1 if only one of the bits is 1. So it doesn't care if all the bits are zeros. To set it 1, but we care if two bits are 1 and 1. So I think that is all about the bitwise operators. But mostly these ones are used when we are creating circuit. They are called circuit boards. These ones, they are not relevant, but it's good to know. Again, it's good to know. I think the other thing that we should learn is the operator precedence. And operator precedence describes the order in which operations are performed. I think most of us are aware of what were we calling it? Is it board mass? And board mass, if you got an expression, let me just check. The guys that are good in maths here. Let me just check something here. I think I should have also a division here. So who will give me answer to this expression? Any volunteer to give me the answer to this expression here? Who is willing to try? That is 2 plus 3 minus 9 times 4 divided by 6.
Zero.
The answer is
Zero.
0. We have Martin saying is 0. Who thinks otherwise? Any person who thinks who have a different maybe opinion?
-1.
That is
-1.
-1. That is a -1. Any other answer? This time from lady Aiga. Is Aiga in? Or we can just have an answer from Faiza. Faiza, what do you think? I think this is just a simple stuff. So where do we start? Who can explain to us? Where do we start to do the operations? I just need someone to explain where do we start these operations, so that at least you can understand precedence. Oh, who will explain to us? Martin, how did you arrive at 0?
It is actually -1.
Now you have decided to change your answer. Okay.
No, I
Tell us how you arrived at -1.
using the bottomers they have written there.
Uh-huh.
Yeah, but of course, mathematically, the multiplication and the division can be manipulated at the same time. So I just said 9 times 4 divided by 6.
So we have.
Which,
Let me just read what you are telling us
yes.
in brackets here. Okay, so you have 9 times 4, that is 36, and 36 divided by 6 is 6.
Yeah.
Then after that,
Then you add 2 plus 3, you get 5, then minus 6, you get -1.
so again you have 2 plus what? 2 plus 3, that is 2 plus 3. Then we have this one minus, and now we are getting this one -5. So now how we arrived at this, by start saying that we have to multiply 9 times 4, then we divide that by 6. So again, when it comes to operator now precedence, again, simply when I talk of operator precedence is same as now as I'm trying to use the Bodmer's rule. So if I talk of bracket being the like in ranked as the first the first one. James, you can mute your mic, please. Thank you. So I'm talking of bracket being being the highest precedence in this board mass stuff here. But now when it comes to operators again in programming, we have now order of precedence, whereby again we are starting with the highest precedent is again our bracket again, and then we continue to exponential, moving to unary plus, unary minus, and bitwise not. So we have that order again. Order is called over precedence. Just as we have a board mass in basic math, again we have now order of precedence in operators. So it's just the same. Is just the same, only that we have added some other operators such as exponential, unary plus, unary minus, bitwise not. Yeah, and bitwise or XOR that. So this is the order in which they are arranged, starting from the one that has the highest precedence, that is the bracket, and the second one is the exponential, moving to unary plus, um, up to where we have or. Uh, so this is in the order in which they occur. So I don't have to explain much about those, because it's just these are just basics. This is just a basics. And again, you don't have to cram all these like at the highest president, the highest presidents, like moving to the lowest, to the one that is ranked last based on the order of precedence. You don't have to cram that. These things, these things will just come automatically when you need them. Uh, so I think that is all about the operators. Um, is there anything left for me to explain? Yeah. If two operators have the same precedence, the expression is evaluated from left to right. This is just a pure what is just a pure a pure implementation of even what occurs in board mass, especially if you have. But I don't think in board mass uh, we have operators with the same precedence. But in case we have the expression is evaluated from left to right, we have addition and subtraction. Like these, both of these have the same precedent, and therefore we evaluate the expression from left to right. If we try to execute these, that is 5 plus 4 minus 7 plus 3. You notice that the expression that we have here will be executed from left to right, whereby we have that is 3 plus 4, that is 7 plus 5, that is 12, and then we minus in 7, or we can just have plus 3 and then minus 7, which is minus 4. Then we have a minus 4 here now, so it's 4 minus 4, which is 0, and then we are left with 5 plus 0, which is 5. So that is what I mean by starting from now. You can just start from is it left, that is 5 plus 4, that is 9. 9 minus 7, that is 2. 2 plus 3. We are evaluating this expression from left to the right. So that is in case we have operators with the same precedence. We say that plus and minus, they have same precedence. Yeah, that is why we are trying to evaluate or execute this expression from left to right. I think that is all you should know about these operators. And I don't think there is any question. And if you have any question, you can just raise up your hand and ask before you move to lists, Python lists. Any question? Any question concerning the operators? You will have to read more about those. But in the meantime, you can get into lists. I think I had mentioned a list somewhere. And lists are used to store multiple items in a single variable. So the variables that we have been having, they were storing just one item, such as x, maybe x is equals to 8. That is a variable storing one item. But now we have a list whereby we have multiple items stored in a single variable. So I think we can just have an example here very fast. Let me just show you how we create a list. And how we do that is just having a variable name. You can have, let me just call it simple list. Simple underscore list. Or let me just have fruits. Let me just have a list of fruits. And we usually use these square brackets, and each item is wrapped with an opening and closing speech marks. So if I have maybe a fruit, you can start with apple. We can have a mango. Can have on what? It's called melon. No, the apple. No, the apple is something different. So how is it called? Is it the melon? I'm not even sure. I think it's the melon. Yeah, this is a list of fruits, and that is how we create a list. We can have a list of fruits, we can have a list of numbers. But in this case now, I'll just have those numbers without wrapping them with the opening and closing speech marks. This is our first list, and this is our second list. So let me, before I drop off, I think I can just check. We can just check the characteristics of a list in Python. And the first characteristic of list in Python is that Python lists are mutable, and by saying mutable, I say that they can be changed. They also allow duplicate values. So by saying talking of duplicate values, I can have, like in the second list, I can have multiple same values, such as 5 and 5. See like this. I can have again a repetition of maybe mango. So they allow duplicate values. Um, List items are indexed. By meaning of index, it means that this one will take the zero what the zero index. This one will take the first index, and this one will take the second index. So they are indexed. So the first item has index 0, the second item has index 1, etc. I forgot something here. List items are ordered, and when we say the list are ordered, it means that items have a defined order, and that order will not change. So if I were to add maybe if I were to add an item, I'll add that item at the end of this list. So there is no way that I can add item at the first index. So that is what we mean by ordered. So if you add a new item to a list, the new item will be placed at the end of the list. And that is it when you talk of ordered. A list is ordered. I think I've explained about duplicates. And what I think we can also have the list length to determine how many items a list has. Again, we are going to use the function that we were using yesterday for len. So for instance, let me just have this one as fruits. These things will keep repeating themselves. I think I can just have change this to fruits. You notice that if I run these, let me just have a copy of these. Let me just try to add. I think I can have I can run these here. So if I try to run these, I'll get that I have three elements in that list, because I use this len function, and then passing the variable name here. So what else do I have to say about lists? Yes, I think we can also check the type. A list with let's say when we come to a list, you can have different types. You can have strings, we can have integers, we can have boolean, we can have another integer, we can have another string. So a list can contain any type of data. So it doesn't matter what type of data it is. So I think that is also something to note, that is worth to note. And if I was to check like this one. If I was to take my list type, definitely I get, if my list has apple, banana, and cherry. If I was to take this type, I get a str, main string. So because I'll share this document. You can try and run this also on your side. Um, we you can also create a string using a list constructor, and how we achieve that is now using what, a list constructor like this one. This is a list. You can rename this one as fruits, and we initiate creating it using the list constructor. You notice that this one is a function. When I talk of a constructor, it it just means that is a function, a list function. Or I can just call it a list constructor. Um, so I just have that list, and then inside it, you notice, but at this time I'm using a parenthesis here instead of a square bracket. Initially we were using the square bracket, but now because I'm using a list constructor, I'll use another. I'll use parentheses to add my items. So I think we can just try to run this and even check its type. I think you can use this cell here. Let me just add another cell here. And can change this one to fruits. So if I run this, I'll still get the output is my list here. If I was to check the type of these, let me just try to check the type. Let me just try to check the type. I'm getting that this one is a list. It is of class list. This one. Let me just change this one to something else. I can try and use the initial method of creating fruits. Let me just create fruits. And this one I can call it underscore one. They have these values again. But this time around I'll have this inside a square bracket. I think I'm getting an error because of indentation. So if I was to check the type of these, let me just try to check the type. You notice that I'm getting also it is a list. Either I use the list constructor or I use the square bracket. I'll still get the same output here. It is of type list. There are so many operations that we can do on lists. We can, I think tomorrow we will be checking these operations. Let me just see this. I think I'll show you some of the operations that we can work on. Some of the operations that we can use in lists, and also we check about dictionary. I think we will also check the dictionary length and how even we can add some items in the dictionary, and then we jump into arrays. I'll also introduce you about arrays and the array methods. Yeah, any question up to that point?
James,
Yes.
will you help me install this stuff so
Okay.
that
I think
tomorrow we can, I will be proud of you.
okay. I think I'll do that after class.
You have another class? Oh, after this one?
After this one.
Okay.
Yes. So any question regarding how we create lists, how we add items in the list, and maybe a question just regarding what we have covered today. So any question? Let me see the people we are sitting in the same boat. The people who are in the same page with me. I think David Mwangi, we have James George, we have ICPL. Yeah, I think most of us we are sitting in the same boat. So I think we can drop off and then we meet tomorrow at 6:30. So I'll share with you this file. Just try and run these programs on your own. Then in case you get a problem, uh, you can just text or call. I think I'll just wish you a good night. Uh, See you tomorrow.
How will I get to James?
I think you can be left behind. And also you have a problem with installing that Anaconda stuff. You can also be left behind.